Everyone thought 3I Atlas was a visitor, a dazzling interstellar drifter passing through our cosmic neighborhood for just a moment, a postcard from another star system. But now, some of the best minds in astronomy, including Harvard astrophysicist Avi Loeb, are asking a question that changes everything. What if it never left? Because this is the story of a comet that broke apart, then broke the rules. An object scientists say may still be inside our solar system, moving in ways no one can fully explain. It began in late 2019. The Atlas Survey, a network of robotic telescopes in Hawaii designed to spot asteroids before they hit Earth, picked up a blur, a tiny smudge on digital frames, designated C2019-Y4 Atlas. Within weeks, astronomers realized this wasn't just any comet. Its trajectory was wider, faster, and hinting at an orbit that didn't belong to our system. It moved like a tourist with a one-way ticket. Then, April 2020, just as it was supposed to dazzle the world's skywatchers, it crumbled. Hubble images showed a chain of icy shrapnel drifting toward the sun. The media declared it dead. Case closed. But decades later, that story would be rewritten, because fresh data suggest part of 3I Atlas survived and did something unthinkable. Fast forward to 2025. New tracking arrays in Chile and Spain spotted an object behaving eerily like the old Atlas comet. Its signal frequency matched archived data from 2019 within less than 0.1%. When asked about it on a Harvard panel, Professor Avi Loeb smiled and delivered one line that set the internet on fire. "I'm not saying it's here to stay, but I wouldn't bet against it." Within 24 hours, Jiker captured Comet was trending on Twitter. Loeb, known for pushing boundaries after his work on ʻOumuamua, argued that if 3I Atlas entered our system at just the right angle, it might have been gravitationally captured by the Sun and Jupiter, spiraling into a long-term elliptical path. This wasn't mere guesswork. Simulations run at the Smithsonian Center for Astrophysics showed such a capture occurs roughly once every 100 million years. And we might be living through one right now. Here's where it gets weird. When scientists plugged the recorded trajectory into Newtonian and Einstein gravity models, the numbers didn't balance. Even accounting for outgassing, the jet streams of gas that can slightly nudge a comet, Atlas displayed a constant acceleration of 0.005 meters per second squared outside expected range. Too precise to be random puffs, too weak to be gravitational. If this sounds familiar, it's because ʻOumuamua showed the same effect in 2017. That's when Loeb first floated his controversial idea that some objects could be artificial, solar sails, or alien tech. Now, with 3I Atlas, the pattern repeats. Nature, it seems, wrote a copy of a mystery and handed us a sequel. In mid-2024, a dim object appeared in the infrared survey data from the Vera Rubin Observatory. At first, it was cataloged as a new asteroid, only to be reclassified months later when its reflective spectrum matched the frozen carbon signature of 3I Atlas. The object was not leaving the solar system. It was closing in, but not on the Sun. It seemed to be locking into a stable loop between Mars and Jupiter, a home among the asteroid belts. If confirmed, that would make 3I Atlas the first known captured interstellar comet, a migrant that decided not to move on. By early 2025, two spacecraft, ESA's Gaia and NASA's Parker Solar Probe, recorded subtle perturbations in their orbital calibrations. The effects were tiny, millimeters of drift, but they lined up with the predicted path of a mass roughly the size of a comet core lurking in the inner asteroid belt. NASA released a short statement. Data consistent with a previously untracked body. We may be seeing Atlas's ghost still tugging on us. Loeb's team combined these perturbations with Rayleigh scattering data and built a 3D model of what a captured orbit would look like. The result was hauntingly stable, a path that keeps 3I Atlas swinging just inside Jupiter's distance. as if the gas giant's gravity caught and kept it like a net. "This is historic," Loeb told a reporter. "If it is indeed a capture, then for the first time we're hosting material from another stellar system permanently within our own." But how do you prove something you can't see? Loeb's colleagues devised a bold plan. Use the James Webb Space Telescope to look for spectral flashes from the region between Mars and Jupiter. If the object still vents CO2 like it did in 2019, those gases would reflect infrared light, the telltale signature of a comet. And then, in June 2025, Webb's instruments found it. A faint pulse at 426 microns. The exact wavelength of carbon dioxide emission previously measured from Atlas. It was like seeing a heartbeat from a comet thought long dead. Avi Loeb posted one word on his blog: captured. The scientific world erupted. Some celebrated. Others accused him of jumping to conclusions. But in living rooms and classrooms around the world, a different feeling spread: wonder. Because if an interstellar object can be trapped by our sun's gravity, then we are no longer just spectators of interstellar journeys. We are their destination. The astronomy community exploded with questions. If Atlas was indeed bound to our sun now, the entire definition of interstellar visitor would have to change. Captured comets aren't common. They're almost mythical. Simulations suggest only 1 in a billion incoming bodies loses enough velocity to stay. And yet, here it was. A case that refused to fade into data archives. At Harvard and Cambridge, students filled halls at midnight to watch Loeb's team live-stream orbital plots in real time. Each loop drawn on screen looked more and more stable. "Think about it," Loeb told the audience. "Something from another star system has found a home here. It's orbiting our sun right now, a bridge between two worlds." The crowd went silent. Then applause erupted like a launch. But not everyone was convinced. Within days, counterpapers appeared from Caltech and the International Astronomical Union. Their claim: the CO2 signal could be a random outgassing from a dust fragment, not a full comet. The object could be a pseudo-atlas, a chunk with identical composition but different origin. Dr. Claire Moreno of the IAU went on record: "There's no evidence yet that this is the same body." Still, there was one problem no one could ignore: the orbit data. Every time scientists ran the numbers, the object fell into a resonance with Jupiter, a 3.2 ratio that acts like a gravitational harbor. Only about 100 objects in the entire solar system occupy that safe lane. The odds that an interstellar fragment would drift exactly there by chance? 1 in several trillion. In the language of statistics, that's a cosmic impossible. Even Moreno admitted on a live broadcast, if this is a coincidence, it's the luckiest shot in the galaxy. Late summer 2025 brought another shock. Radio astronomers in Australia detected a repetitive broadband pulse emanating near the predicted coordinates of Atlas. Too weak for communication, too periodic to ignore. The pattern mirrored a thermal cycle every 8 hours, the exact rotation period recorded for 3I Atlas before its breakup. Was the comet somehow still responding? Its day-night outgassing creating that steady metronome of heat and cold? Or was it something else, a natural signal becoming artistic in repetition? One reporter asked Loeb if he believed the object could generate intelligence-like data. He smiled, half serious, half wry. "I believe it's sending information. It's just called physics." In October 2025, the Vera Rubin Observatory released a time-lapse of the object's motion spanning 3 months. The track was complete. A closed ellipse around the sun with an orbital period of 7 years. It wasn't escaping. It was home. The paper hit Nature Astronomy 2 weeks later. Evidence for solar system capture of interstellar comet 3I Atlas. The co-authors list read like a who's who of planetary science. And there it was again, Avi Loeb's name right in the middle. He did a single interview for Cosmic Atlas. We asked, "Professor, does this mean we can call 3I Atlas a resident of our solar system now?" He leaned back, hands folded, and answered quietly, "Yes, and perhaps it's not the only one." Imagine what this discovery really says. For years, we believed interstellar objects were brief ghosts, passing through before vanishing into the dark. Now, one of them may be bound to our sun forever, a permanent ambassador from another system circling within reach. Already, space agencies are drawing up mission concepts. A probe that could rendezvous with Atlas by 2032, sample its material, and return to Earth. If successful, it would bring us the first hands-on evidence of matter born around another star. We'd learn how its ice formed in unfamiliar temperatures, how its dust records the chemical signature of a foreign sun, and perhaps see what our own solar system looked like billions of years ago. And in those tiny particles, we might find clues to a bigger story. How life's ingredients connect all stars into a single continuum. Yet, as the dust settles, a new question emerges. If our sun can capture something from another system, what else might be drifting out there, waiting to be caught? Could Earth itself have been seeded by such visitors? The very comets we once ignored? Loeb has a term for this idea: cosmic archaeology. Digging through space not for artifacts of alien civilizations, but for the fossils of alien worlds. Each captured object becomes a chapter in a galactic autobiography still being written. He said in his closing remarks, "When you look up, don't just ask who's out there, ask what's been left behind." Of course, no discovery comes without its shadows. Online forums sparked with wild claims that 3i Atlas was parked deliberately, a beacon watching Earth. Pseudoscientists linked its arrival to satellite failures, to aurora bursts seen at unusual latitudes. But real scientists responded with something better than denial: more data. Every observation, every measurement confirmed there was nothing magical, only magnificent physics. And perhaps that's the beauty. Even without aliens, the universe still finds a way to astonish us. Tonight, somewhere beyond Mars, a small frozen body slides silently along its new orbit. It doesn't know it has become famous. It doesn't care that we argue about its name and origin. But if you could stand on its surface right now and look back toward the sun, you'd see our world as a tiny, pale spark, the same way it once looked toward ours before crossing the Great Dark. Captured or not, it's here for a while. And in the vast, cold equilibrium of space, that while might be longer than humanity itself. Narrator, soft, inspirational tone, maybe Avi Loeb is right. Maybe 3i Atlas is just the beginning of a bigger pattern. Perhaps our solar system is not a sealed home, but a living harbor, collecting the stories of wandering worlds. We spend our days searching the sky for company. And all along, it may be the universe that's been searching for us, through comets, through dust, through every tiny grain of matter that decides to stay. So tonight, when you see a meteor streak across the dark, remember this: not everything that falls burns away. Some things choose to remain. This is Cosmic Atlas, where curiosity never leaves orbit.